So on the agenda today is give a little bit of introduction about who Powerlink is, our asset monitoring strategy that we've been working on since back in 2000, our digital transformation, so what have we been doing since we put forward that asset monitoring strategy, and give you a few examples. And it's all about turning the data, which is relatively easy to capture. The challenge then is turning that data into information and then making informed decisions based on that information. So I'll take you on Powerlink's journey. So first of all, who is Powerlink? So we're the transmission company in Queensland, and got quite a large network, 15,000 circuit kilometres, and 132 substations about Queensland. And now I'm going to use technology, if it should work, to clip in the hyperlink.
So, what is the transmission network? The transmission network links large power stations that produce electricity with the distribution network that delivers electricity to homes and businesses. Our network extends 1,700 kilometres from Cairns to the New South Wales border, comprising more than 15,000 circuit kilometres of transmission wires. To travel these vast distances, electricity is transported at up to 330,000 volts via our high voltage transmission lines. This voltage is progressively lowered by substations as it travels across the transmission and distribution networks before being delivered to homes and businesses at 240 volts. We also supply electricity directly to high usage customers such as mines, gas processing plants, rail and aluminium smelters. Each year, Powerlink transports 45,000 gigawatt hours of energy across our network.
Right, so Powerlink's asset monitoring strategies, this started back in 2000 when we saw that the whole raft of digital technology was starting to arrive in our substations, and we had lots and lots of data. But then the question was, well, what are you going to do with it? And where are you going to use it, and what are you going to use it for? So we put together the asset monitoring strategy, put that to the board, and they signed it off. And fundamentally, it's about using that data, so that the data capturing the substations, then communicating it, getting it to the right spots, so bringing it back to the head office, putting it into databases, allowing software tools to integrate that data together, and then running, again, software tools across that data, looking at simple trends, highlighting things that need to be investigated, and then when we got more advanced, is that some more advanced software which allows you to do more detailed analysis, which allows us to make more informed decisions. And that was 17 years ago, and we're still on the journey. Just as you get some of your software tools working, you find a new opportunity to use the data in some slightly different way. And I'll give you a couple of examples as we go through the presentation today. We heard about from previous speakers, it's not necessarily just technology and technology for the sake of it. It's got to really benefit the business, and to that front, it's really got to benefit the customers. What we're doing, we've a very strong focus on what's in the best interest of our customers and consumers. Because if we're not doing the best thing for them, then it's going to be detrimental to our business model. Electricity customers have now got alternatives to using just transmission and distribution electricity. And if we want to make sure we're still in business in 10 years' time, we've got to very much have a focus on the customer and consumer. To do that, we'll leverage off the technology that the suppliers such as ABB can provide, and look at how best can we use that to forward our customers' requirements. And that requires a bit of a paradigm shift in your thinking. And for example, we've moved from analog protection relays to digital protection relays. And that's required different skill sets out in the field. And it's allowed us to change our maintenance practices to reduce our maintenance costs. But when I've talked to other transmission companies around the world, and they've done exactly the same, they've moved from analog protection relays to digital protection relays, but they're still doing the same maintenance practices they used to do with the analog ones. And they're missing out on all the cost savings and benefits to be achieved. So you really have to have that, I dare say, that ability and agility to actually do things differently. If you're actually putting these systems in place, if you don't actually change what you're doing, you're not going to get the full benefit. And it's not just technology for technology's sake. You've got to really kind of pull it back to that business benefit. Looking at the, I dare say, the technology roadmap we've been on now, really in that kind of 2000 period to about 2009, 2010, was quite a change where we adopted quite a lot of new technologies. The network was expanding over that period. We had a whole raft of assets were requiring renewal, which allowed us to then roll out quite a lot of new substation technology. So as I say, digital relays, the rollout of fibre optics to our substations, providing telecommunications. So there was quite a lot of infrastructure put in at that point. And then similarly, the software systems to support that in those latter years. So we started to feed that in. So there's quite a huge change in the business at that time. For example, we actually set up an asset monitoring team, which was dedicated to actually using this digital technology to support the customers, and that helps reduce cost, but also improve reliability and safety on the network. Over the last 5 years, we've probably been in a period of more consolidation and really looking at how do we kind of really leverage off the equipment and systems that we put in over that previous 10 years, updating the software to do the analysis, and I'll show you a couple of the examples of what we've done there. And as I look forward over the next 10 years, I see there's going to be a requirement for, again, a step change. Why do I say that? Fundamentally, there's huge changes happening in the electricity industry at the moment. Whether that be solar panels on people's roofs, whether it's the introduction of storage, so you can start to see that happening. We've got large-scale renewables. We've got over 100 inquiries wanting to connect to our network at the moment, so 100 megawatts and above solar PV. So all of these things are really going to kind of challenge the way that we operate the network in the future. And by embracing the technology that's available and will become available over the next 10 years, will allow us to do things differently again. So I think over the next 10 years is going to be quite an exciting period in the electricity industry. So looking back over the first years from 2000 to 2012, so for those of you not in the electricity industry, so there's a picture of a substation. We've got about 130 of them about Queensland. And that's for basically switching in the networks and for stepping the voltages up and down from the generation and down to the distribution companies. And you can see there's lots of switches which allow you to reconfigure the network, and also there you can see they're the substation demountables, and that's where the digital technology is, and that's where the brains of the substation live. And that's a change from where we were building them in the 90s, because in the 90s we had just one large building, and we put all the brains and the protection systems in there. And we had about, 4 panels, so whatever the large panels per bay, whereas now in those areas we're getting a bay per panel. So we've actually reduced the footprint, which allowed us to go into these demountables, which provide a lot of benefits. So all of a sudden you don't have cabling from one end of the yard to the other. The cabling's much shorter, but also gives you a lot more flexibility when you're actually going to build. And you can actually do the factory acceptance testing. You can build them all in the factory, do all the factory acceptance testing there, and then ship them to site on the back of a truck. It saves you having to do so much testing on site. It helps you manage those project timelines, costs and risks. So just helps put things into context. A plug here for my hosts, ABB. So we had introduced our hybrid switchgear around about that early 2000s, and it allowed a number of things. One was to reduce the footprint, the size of the substation, but also allowed us to I dare say, get an awful lot more data from the switchgear. So it allowed you to then look at SF6 gas density, the travel times and the circuit breaker, provide a lot more condition monitoring than what we had previous on other switchgear. It also then had fibre optics, so fibre optics to the demountable, and allowed some cost savings in reducing the aspects of copper wiring. And but the main thing was that's where the strategy kind of started. I said, well, hang on, we've got all these things capturing data, but how do we actually best use it? Because our substations, and some of the substations are 6 hours drive away from the depot. So there's no point in having the data sitting in the substation. You need to actually bring it back to base. Here's a picture from inside the demountable. And as you say, we're now at the point of doing a bay, the brains for a bay in one panel, and allows you the efficiencies then get all into a demountable, which you can put on the back of a truck. A lot more flexibility for delivery, and improve safety. So it saves you having to drive to site so often to do the testing. And if you're driving 4 hours to site to do the testing, then obviously it's very expensive, but also then the risk on the roads. The telecommunication systems, I said it's great having these systems that capture data in the substation, but it really only provides value when you can actually start to use the data. So you need the communications to actually get it back to the head office, or where you can actually then put it into databases and start doing your trend analysis. So we're fortuitous in a number of our earth wires and our transmission lines. So they're the ones that go at the very top of the transmission towers, protect it from lightning. So a number of them were needing to be replaced. So when we replaced them, we actually replaced them with earth wire with fibre optic down the middle of it. And the actual cost at the point when we were buying it, we could actually buy the earth wire with the OPGW cheaper than we could buy standard earth wire at the time. So when we ever did a restringing, we used OPGW, and that's provided it was a very high-speed comms network right across Queensland. And that's allowed us to start to bring some of this data back. It's also we've used that in for our protection relay communication as well, and allowed us to move away from microwaves. So they are inherently more expensive, less reliable, and so as they've come to their natural end of life, we've replaced them with the modern digital equivalent. Another thing we've done is we have now cameras in all our substations. Now you've got communications, high bandwidth, so we've got remote control cameras that allows us to zoom about in the substation. And so if you're 4 and 6 hours drive away from a substation and you've got an alarm, it allows the team that we set up, so a dedicated asset monitoring team, to actually then log into the substation and pan around and see what's been happening out there, and then allows them to do their fault diagnosis. Just to put that into context, that we had only yesterday we had an issue at one of our substations. A piece of equipment didn't operate or maloperated and turned off some of our customers. The substation in question, this one, was 3 hours drive away, and the team were able to log into the OpsWAN system, download the data, identify that the piece of equipment had maloperated, and then switch the network back in within 45 minutes. So within the breakers operating, the customer being turned off, to actually turn the customer back on within 40 minutes. Now, I say it's 3 hours drive to the substation. So if we didn't have this system in place, you could be working, or customers could be impacted for an awful lot longer than 45 minutes. Then we've got the systems that once the data comes back to the corporate head office, the systems which allow us to do some of that analysis. So we have an energy management system, which allows us to control and operate the network on a 24/7 basis. But it also then pulls in all the alarms from the network. So it allows us to put them in and then into quite a large database, which then is to do some trend analysis. So you can have a look at, and you can see toggling alarms, you can see breakers which are operating, when was the last time the breaker operated, there are some particular ones on capacitor banks which are switched more frequently, and saying, well, hang on, perhaps we should be switching in different cap banks rather than the operators. Some operators have their favourite cap bank, so they always switch it in and out, but maybe they should be using the other ones so that you share the duty across the different circuit breakers. We also have an enterprise asset management system, which then records the faults on the network. It's linked to the finances as well, and then you start to put a little bit of the condition monitoring information in there as well. So all of a sudden you can then start to trend analysis and say, well, what was my most reliable or least reliable piece of equipment on the network? And then you can start to tie that together with the EMS, and I think that's where the power comes, is when you can actually start to integrate some of this different data sources together and do some in-depth analysis. We've also got a GIS system, and when I spoke to the person who's looking after my GIS system, they said, oh, Stewart, the GIS system is going to be the data repository of the future, and that's it's going to be great. Now, he might have been slightly biased, but I do see that there's some great value in being able to see your assets as they sit from a geographic perspective. But you need to then link that together with your fault data, your operational data, to get the whole and big picture. But the key, I suppose, is to have those. Only try and keep your data once. I know that sounds simple, but it's amazing when you start to get data duplication. So only keep it once, and integrate the different systems together to help lower your management costs, your data cleansing costs, because they can be quite substantial. Through the consolidation and optimization stage that we went through. So we're still looking at further opportunities. We looked at and introduced the 61850, which is an international standard for substation automation systems. So we've actually introduced that at the station bus level. The next level is to go then to process bus, where you start to have fibre optic out into the field. So we haven't got to that stage yet, but we've got the protection relays. You need to have an X and a Y, so a primary and a backup protection relays. So they're actually talking using this international standard. We've continued to roll out technology to the field crew. So we've now got tablets that they run when they're doing their maintenance activity, which allows them to capture photographs and asset information. And then when they come home at night, they dock the tablet, and that loads it automatically into the ERP system. Certainly a big step forward from where we were 10 years ago when I was trying to get the information on the telecoms sites. And they said, oh yes, we do our routine telecoms visits. I said, excellent. So where is the data? It's in a filing cabinet. Oh, because they go around, they tick all the boxes, everything looks good, and we put it in the filing cabinet. And the filing cabinet's not even in Brisbane, it's in Rockhampton or Townsville. And I'm like, well, can I have a look at it to then see what's happening in that area? Well, no, they're our documents. I said, we'll have to photocopy them and send them down to you. And you're thinking, yes. So also we've gone past that, and we've now got that all happening more automatic and in a centralised system, which allows you to then do the analysis. We've also introduced a system to look after our telecommunications network. So with that flexibility and agility you have with the fibre optics, you've allowed many different communication paths with backups and automatic failover. But it's much different to the static system that we had in the microwave days, which we used to capture and look after using drawings. So when you've actually got then the more agility and functionality, you can't keep up with a drawing management system of how things are all configured. So we've introduced a tool which allows us to keep track on our telecommunication assets. Also rolled out a data warehouse, our kind of asset information hub. Actually to start to pull some of the data from these different systems into one area, but also to run like data cleansing tools over it to look at your data quality. When you do that, you identify, oh, hang on, I've a few holes that need to be fixed. So So there's tools available now that you point to a data warehouse, run some checks and balances, and you can actually then start to pop out and say, well, hang on, how good is our data? And in some areas you might get a little bit of surprise that it's maybe not as robust as you would first like. And similarly, we've been using some of this asset data to then feed into our risk and optimization tool. So looking at information from our GIS system to say, well, where are the transmission lines? Where are they close to houses? Where do they cross roads? Where are they at more high risk compared to in some regional area where they're in a very, very remote area away from the public? Using that information coupled with information on asset information health indices to then say, well, what's the probability of failure? What's the consequence if it does fail? And then feeding that into our system, it basically shows how the risk on your asset changes over time. And as that increases, the business case to do something also increases. And then at that point, it's time for investment. But we've also tied that in with our portfolio tool, so it allows you to do some portfolio optimization. So what we're actually seeing is where we might have lumped some assets together to get replaced. So, for example, line insulators, along with upgrading a transmission line, doing a line refit. And we might actually then say, well, the line refit's not mission critical, we can defer that for another year. But all of a sudden, the line insulator replacement is mission critical and has to be done within that year. So all of a sudden, when the portfolio managers start to move that project 12 months, it then flags up that we've got an asset risk and that you have to actually split that project in two to do the insulator replacement and then the line refit at a later point. So it's being able to manage our assets and understand the risks associated with them. Looking at the GIS system, so this is Cyclone Debbie. It crossed the Queensland coast a few months back, and we actually linked the BOM, the Bureau of Meteorology's data, with our GIS system. So we had in real time, we could actually see the BOM's forecast for the cyclone and its path that it was expected to go on, and then look at where our assets were, so which assets were going to be in the path of the cyclone, to then say, well, hang on, which ones were at highest risk from the high winds. So that was excellent to have that in your corporate emergency management team information. And you can see there was an excerpt there about some flood mapping. So after the cyclone passed, all the rain hit, and then there was significant flooding. In one particular area, they had concern that the flooding was going to go up and say, well, hang on, is it going to get close to your substation? So again, we linked the BOM's data, the flood levels and our forecast for flooding against our assets, and then we could actually then prove that yep, whilst it was forecast rises in the river, it was going to be well below where our substation was, to give you comfort that that asset wasn't at risk. So again, that's very, very valuable when you've got the government and the energy minister asking questions about will your substation be okay or not. And the guys didn't just stop at one substation because they've got the data now. They've did it for all of our transmission towers across Queensland. So they took all the BOM flood forecasting data and then mapped that with our assets to then say which ones of our transmission assets were going to get their feet wet. And there was a few of them, but at least then we knew which ones, and then we could prioritise the aerial patrols to make sure that everything was as it should be. So again, just another example of how you can use the data to convert it into information to help inform your asset management decisions. Then looking for the next 10 years, the national electricity market is transitioning. You've got talk of Snowy 2, so we're going to have large pump storage on the network. We're going to have a lot of distributed storage behind the meter, because if you speak to your electricity retailer, they're more than happy to sell you a solar and storage package right now. Now, it's not very cost effective at the moment, but rest assured, in the next 5 years, the cost of storage will follow the same reduction that we've seen with the cost of solar PV. and all of a sudden those networks and those systems will start to become cost competitive. At the same time, we're also seeing large-scale renewables connecting to our network. So you can see there's a lot of wind connecting down South Australia and Victoria, a little bit of wind in Queensland, lots and lots of solar. So we've got large-scale solar. So as I said, there's about 100 inquiries of 100 megawatts and above. Now, not all of them will fly, but we've had 750 megawatts connect onto our network in the last 6 months. So that's huge. If you think of the things about 1.5 gigawatts, so 1,500 megawatts of residential solar panels on our roofs in Queensland. So you've basically put half of that again with large-scale renewables just in the last 6 months. And the indications are there's significant amount to be added. Challenge for the network then is, well, hang on, what do you do when the sun shines? That's great, but then what type of constraints do you have on your network to get the generation to where the demand is? And then what do you do when the sun sets? So that's where you need to have diversity of your generation. You have to have wind and solar, or lots of network, or lots of storage, or in some cases, demand response. So traditionally we've built our generation and our networks to meet the demand. But as we've got more intermittent generation, perhaps it's time that we now start to modify our demand to match the generation. So all of these things, there's no silver bullet. It's not go out and build lots of network. It's not we'll have lots of storage. It's we'll have lots of demand management, because we may not have as much as you'd like. So how do you balance all of those things going forward? And it's a tricky one from an investment perspective, but also how do you use the existing assets you've got to their best ability, and then use the new technology is coming, to then integrate with that to get the best outcome for customers and consumers. It's not the best outcome for the network companies, but what's best for customers. And the energy trilemma, this is not just an Australian thing, this is from an international perspective, but how do you find that right balance? So it's very key. People are very keen for renewables, and ideally you'd like 100% renewables from your electricity. So that's a great target to have. At the same time, you want to have reliability and security, so that when you flick the lights on, flick the switch, the lights comes on. So you want to have that all the time. And then you want it at a reasonable cost, so which is fair enough as well. So how do you find the right balance between the sustainability, the energy security, and the cost? And the transmission network plays a critical role in all three of them, whether that be connecting the large-scale renewables, the energy security and providing that diversity and that backup, and then from a cost perspective, because everything we do goes on to you and I's electricity bills. But the digitisation has the potential to support in that area. So how do you put downward pressure on electricity prices? So in the future, we're going to have distributed storage behind the meter, and we're already an evening peaking network. So how do you use that storage to reduce the demand at night, and how do you make sure it's charged appropriately during the day? So all of a sudden you need less network, you need less generation, because all of a sudden you can bring that maximum demand in the evening, bring that down and bring that demand up during the day, and you get better utilisation of your electricity assets. So how can we use the technology we've got available to achieve that? Because that will be a great outcome for electricity consumers and for industry generally, if we can put downward pressure on the price. Customer and consumers empowerment. So once you've got your storage device and you've got your solar panels on your roof, you might actually want to sell that. So the networks can help facilitate that market. So what information or what data do we have to transfer about? Because all of a sudden you think, well, storage, excellent. Well, I'll call upon the storage, and I'll pay you to provide that demand response in the evening. But all of a sudden you need to know how big the battery is, what's its capacity to export, its size, how much charge is in it at that particular time, and then the person's willingness to bid into the market. So all of a sudden you've got all of this, I suppose, data that somehow needs to be communicated through the system to actually make sure it's all coordinated. And that won't be an easy task. Improving network functionality, the performance, reliability, flexibility. We're actually using protection schemes and run-back schemes at the moment, so it's not just systems that look within the substation, but look right across a number of substations. And if that particular event happens, then it allows you to then curtail generation or the capacity of the network after that particular event, which allows you to get more through the existing network right now. So looking at how do you use those smarts to connect more of this renewable generators at the least cost, which will benefit the consumer. So technology has some great opportunities for us in that space. At the same time, we talk about asset management. We've got $8 billion of assets, which are growing older and older by the day. So we've got to make sure that we use the systems we've got to actually make sure we manage them correctly. We've got an awful lot of transmission lines which are having a 50th birthday, and that's typically about the length of life that you'd expect. So we need to make sure that we're very sure that they're coming to the point of needing reinvestment, and then what do you reinvest? Typically at the moment we're looking at extending the lives if we can, rather than replacing them. So doing some member replacement, some bolt replacement, to keep them going for the next 15, 20 years so that we can get a bit more surety what's the longer term need for it. It's very hard to go to the board when you've got a 50-year asset to say, yep, I'm going to get a return on this asset for the next 50 years. So we've got to be very careful so what we can eke along and which ones can we actually then maximise the throughput on are certainly options that we're looking at very, very closely. And then managing network complexity, so I touched on that. So you talked about battery storage, distributed generation, demand management or non-network solutions. How do you actually pull all that together? And how do you operate the network of the future? So our energy management system was put in about 20 years ago. It's had a couple of mid-life upgrades and it's come to end of life. So over the next couple of years we're going to be reinvesting in a new EMS system, and we've got a very watchful eye on what the future may hold and how do you have that flexibility of that new system going forward to support the operator, because it won't be as simple as operating the network we've got just now. It's going to be far, far more complex. So how do you operate it? How do you automate the operation so that you don't have to end up with half a dozen operators in the control room at any one time? Other investigations that we've got on at times, so looking at these wide area protection schemes, so special protection schemes, or looking at phaser measurement units as well. Again, it's all about trying to get more out of the existing network. If we do that, then say there's benefit to the customer and consumer. Real-time network harmonic management systems. And a couple of my colleagues out in the audience will be able to talk to you in more detail if you want to find out about them. But again, it's about power quality. So how do you make sure that the reliability and security of the network is maintained? Because otherwise, people look at alternatives and say, well, I want to stay connected to the network because it's reliable. What happens in 5 years' time if the network's not reliable? Why would you stay connected then? So it's really, really important to make sure that we don't drop the ball on that power quality and that reliability. Talking about the next generation operations, so that's about the replacement of the energy management system and the system controllers, so how do we operate the network of the future? And then looking at things like drones and automatic photo reviews. Now, drones, so you saw the Ops WAN cameras, so we've got cameras we can pan around and look at the switchyard. So what we've now got a vision of is, you talk about those VR goggles that you put on. So we've got our people in the control room, you could actually put that on and you've got a drone that sits in the substation. And it can just fly out of its little drone hopper at the substation, and you can actually then fly around on preset paths around the substation, so you can actually then hover in front of particular pieces of equipment to get a close look. So all of a sudden it'll be like you'll be in the substation, but using the drone. So we've got a bit of R&D working in that space. And then similarly, all these aging transmission towers we've got. Now I've got lots and lots of photographs of aging transmission towers. But then how do you then work out and do a detailed condition assessment of which ones are the ones that need the investment and how much is it likely to cost, so that you can put a project up to the board. So what we're looking at now is, can we use those photographs and then use some technology to run over the top of that to say, well, yep, that particular tower has 200 rusty bolts of grade 4 corrosion need to be replaced, and it has 400 at grade 2 and a dozen at a different grade. So all of a sudden you're starting to use that to actually justify your business case for asset reinvestment. So there's lots of new and wonderful ways we can use this data to help in our informed decision making. Looking at the next stage of IEC 61850 and looking at process bus. Fundamentally, that's allowing us to basically use fibre optic from the measuring devices through to the control room, and then all the way back again to actually then trip the switches, which gets it away from a lot of copper in the substations, which will be an awful lot easier to install from a cost perspective. So looking at how do we leverage off that. So other things we're looking at is these non-conventional instrument transformers. So traditionally we've used CTs and VTs using technology which is 100 years old. However, some of that plant does have safety risks from our perspective. We do oil sampling and other checks and balances. But if we can move to more of a fibre optic arrangement, then A, it's a lot easier and cheaper to install, and B, it's an awful lot safer for the guys out in the substations as well. So we're continuing to look at that rollout and when it's timely for us to adopt that. So we've got a couple of trials on at the moment. And I dare say, ultimately one day you'd like to have some plug-and-play relays that you can actually then pull them out and pop a new one in. We're not quite there, but perhaps over the next 10 years we will. So challenges, it's not all milk and honey. So cyber security, so there's a presentation this morning talking about cyber security. So as we do more and more digitisation, you want to take the data from the substation back to the office to do the analysis, but when you put data one way, then there's holes or potential holes to get back into the substation. So an awful lot of checks and balances to be done there to make sure that everything is secure from a cybersecurity perspective. Again, it's about affordability. So can we actually buy this equipment at reasonable cost, which then balances some of the benefits that we'll be able to achieve from it. And we want it to be following an international standard. At the moment, the 61850, it's a bit like myself, there's different accents of 61850, and sometimes you don't understand exactly what it's talking. So we need to get past that and get more back to that level common understanding. And similarly, it's the design tools. So it's not just about the equipment, but can we have the design tools which allow us to then design these systems cost effectively? So we see that's very, very important as well, because these devices are very, very complex, can do great things, but then how do you make sure that you design them appropriately and cost effectively? Other challenges we have is you start putting more and more electronics out into the substation. The substation can be pretty hot at times. It can be also pretty wet at times. So how do you make sure that the electronics is robust enough? It's okay having them in the air-conditioned demountable, but as soon as you start to put more and more smarts out into the substation, you've really got to make sure that they're robust enough. And ongoing data management. And whilst the previous speaker talked about data management, data is very cost effective now to capture data. It's never been cheaper to store it, but rest assured, it's not just about the storage cost, but how do you make sure that it's the right quality, and then what you actually want to do with it anyway. So it's a never-ending challenge is your ongoing data management. So in conclusion, Powerlink's been historically an early adopter of this digital technology to see how we can leverage that off for the benefit of the customer. I see over the next 10 years that we're going to have to really leverage off the technology and the opportunities even more as things change, as the whole electricity industry's turned on its head. And we'll continue to leverage off the technology that's available. But again, our compass is based on the customer and consumer.